Hello and welcome back to Advent of Code 2023, even though as I'm recording it, it's now 2024. I know it's been a while since I did my last video. Turns out December is a terrible month for me recording videos just because there's a bunch of family stuff and friends and stuff to go to over the Christmas period. And also I got a terrible cold/flu thing over the Christmas period as well, so I've just not had much time to record things. But I am going to get back into the swing of things. I'm hoping to get through as many Advent of Code day puzzles as possible. Now I have, first of all, I have put the stuff I've done so far up on Github. So we've done day 1 and 2 so far. We are about to do day 3. So if you're looking for this, if you just go to github.com/perky /AOC 2023, I'll put a link to this in the description as well. Another thing also is over the Christmas period, I did do days 3, 4, and 5 without recording them. So I am going to go through and do day 3, 4, and 5 from scratch again. I'll be able to speed through those pretty quickly because I've already done them, but for the sake of completion, I want to record all possible days as I can. So let's get stuck into it. So I've got my day 3 zig ready here. So if we go to our Advent of Code, so for day 3, and I'm just gonna have a read through that. Let me make this a bit bigger. Here we go. Okay, so you and the elf eventually reach a gondola lift station. Cute. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, which is our puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol, and here's an example. So basically we're going to get a 2-dimensional map. The dots or periods, they're just blank spaces in the map, and there's going to be a number, and there will be a symbol. In the schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. So 114 is not a part number because if we look around it, there are no symbols, even diagonally. And 58 here, again, if we look at all the cells around it, there are no symbols. What is the sum of all the part numbers in the schematic? So, like I said, I've already done this, so I know the answer. So I guess we just need to code it from scratch and double check that this is the answer I get. But before we do that, I am going to copy the test data and put this into our test file. I think I've already got that here, yeah. Okay, so and then we go to our, let me close all these out. So let's go to our day 3 and let's get stuck into it. So we're going to need our usuals, which is our standard. We're going to need our line parser. This is the class that I've made to help parsing lines of the puzzle input. That's line parser, not zig. fs is our file system, so this is again code that I've written to just abstract away some of the reading and writing files. Raylib, that's the sort of the game engine library that we're using to render things on the screen and play music and stuff. And then C, because Raylib is a C library, we're going to get all the C functions are namespaced under C. So then every day xx.zig file needs a public method called process. So allocator, standard mem allocator, and that returns a solution. And our solution is just our struct. So we have a subconst solution equals struct, and what else? So that will have our answer, and we'll just do our now, and we'll return the solution. I believe this is, sorry, in the wrong syntax. We don't use allocator right now, so we'll just do that. Cool. And we go back to main.zig. We're going to import day3. And then we need to append this. So if I just copy this, this is day3.process, day3 solution. So this is also a new thing that I've added, again, just because it sort of abstracts having multiple days. I've created a thing called an iDay, which I stands here for interface. There's quite a bit going on. It can be a little bit hard to parse what this is doing, but essentially because each of our days is essentially an entirely new type, especially the if you look at the solution, this structure that the days return, so they all have the same function signature apart from the type it returns, even though it's got the same identifier solution. They're actually different types. This is like day 01 dot solution, and this would be day 02 dot solution. So what this does, if I go back to main, is it effectively sort of abstracts that draw function. So it takes a pointer to any opaque. So if you're used to C, this is basically a null pointer, and then I cast that pointer to a type. So this iDay structure, when I init it, I pass in a pointer. So if I look at this, I init and I pass in a pointer to the solution structure, and then using Zig's type reflection, I can figure out what the type is. I store that in this variable t, and it generates a new structure with this function called draw that will cast this sort of null pointer, void pointer, sorry, back into that type, which means I can just append all of these into an array or a list, because usually I wouldn't be able to append a whole bunch of different types into an array because they would all have different sizes. And And I mean, I could just have an array of any opaques, like avoid pointers, but at least this way it's just a little more verbose and explicit about what I'm doing. And then in my while loop, if I go where am I looking? Here you go. Depending on what the active day is, I just index into that array and I call draw. And because as you see, the pointer is a member of the structure, it sort of that implicitly gets passed in to the draw function. I think I did a terrible job of explaining that. But if anyone leaves comments on this video wanting more thorough explanation, I can always do that in the next video. So anyway, we got our day 3 solution, day 3, days append, and now I don't need to do anything else because that's now appended to my array of days. So if I just run this now, oh yes, structure day 3 has no member called draw. So yes, if we go back to our day 3, let me save that. This needs a function called draw that takes a pointer, a const pointer to itself, an allocator, and the delta time. And it doesn't return anything. For now, we're not doing anything with these arguments, so we will explicitly unuse them. And now if I run it, it works. So there's another nice thing I did off camera is I added a little bit of a snow particle simulation. I cleanly arranged all the buttons, day 1 to 25, in a nice little grid. So the days we haven't implemented yet will stay grayed out, but the days we have implemented, we can go ahead and click and it'll go into that page. I can hit backspace to go back to the chapter menu. So each of these days are working. Again, I can hold spacebar to immediately show the answer. And we've got day 2 here. And obviously we still get, and there's a nice little, I don't know if you can hear it in the recording, but there's some nice little background music as well. Just some twinkly music. Okay. So let's go back to day 3. Yeah, we are here. So what do we need to do? So we need to pass this test. So I think the first thing to do is to go ahead and just pass this into some kind of map structure, as in pass this into a kind of a 2D map, and then we can reason about it more effectively than just trying to reason about it mid text parsing. So the way to do that is pretty simple. So we're going to create our line iterator. So we go to our file system, that's where we specify our line iterator, and then we need to initialize that with the allocator, the number of the day number, include empty lines, false. So if I just go to that, this is our line iterator. And it's just abstracting away, reading the puzzle input from the file and creating an iterator so we can either split over it. This include empty lines thing is, I might have covered this in the previous video, but sometimes we care about whether we want to include, say there was more lines in this, whether we want to read these empty lines or just skip over them. So, but for this, we don't expect any empty lines, so it's fine. We'll just leave that as false. And then to iterate over this, we'll do while line iterator next, and we'll get the line. And we are using the allocator now, so we can do that. Okay, so we will now, once we've got the line, we want to create a parser for that line. So we'll do line parser init line, and then we are going to want to process this into some kind of map. So we're going to create a structure called map, and this map will have a width, shall we say usize, and a height. Usize, by default they start at 0 because we won't know what the size and width is. And then if we get our, let me just go ahead and put that there. Oh, sorry, this, I'm going to increase the font size. I've just realized it's been a bit small for recording. Let me put you there. That's a bit better, isn't it? Okay. And make a bit more space. Here we go. So yes, so I think what would be better is if we convert these into cells, maybe. So each of these would be a cell. The only thing is these numbers, we don't actually count an individual digit as a number. We're reasoning about the whole number. 400, this is 467, not 4, 6, and 7. So if we're going to split each of these into cells, the cell will have to indirectly refer to the whole number as well. But for now, let's just say, okay, cells is going to be a array list of it'll be a bounded array. Yeah, we're going to create a cell array, a new type called cell array, and this will be a bounded array. For now, it will just be a single character, which is a U8, and I mean, right now this is like how many cell? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10 by 10, but I don't know how big the puzzle inputs was. Can I get my input again? Oh yeah, puzzle input. Okay, so that's much larger. Actually, let me put that into, I think I've already got my puzzle input here, but let me just make sure. So there's 140 and column, so that's 140 by 140. So let's just say that's 90,600. I'm going to make that an even 20,000. Okay, so here's our cell array. So we now need to initialize this map. So I'm going to do that. So var map equals try allocator dot create map, and we will then need to initialize it because this will be uninitialized data. So equals map, and the cells will equal try. So there we go. So this is going over each line. So we can start to update the height for each line. We'll increment it by 1. And then we will, let me just look at my notes. The width we can just set to the map.width can just be equal to the line len. It's just how many, yeah, it's just the length of a line. That's the width of the map. And then, okay, so while parser is end, so while we're not at the end of the parser, do we not have, oh, it's called line parser. There we go. We're going to check. So what we're going to do is we're going to get the char. So const char equals parser peek char. Sure. So we're going to peek at the first char. If standard ASCII is digit. So if that char is a digit, we are going to read that number. So const okay, yeah, if this is a digit, we're going to read the whole number, right? So we're going to say, okay, the whole number is equal try parser read number I32. I also want to do, I want to cache the cursor, so where we're up to, and then I want to append, oh, let's see. Tell you what, to begin with, all we want to do is just do a map dot cells append, and we're just going to append that chart, right? Do I not have a function to read a single char? I've got peek char, but I don't have a read char. I guess I could just do parser.cursor plus equals 1. Let's do this for now. I just want to make sure that this is working. So that's going to do that, and then we want to store this map, so our solution will have a pointer, So it'll be a map, pointer to a map. Yeah. And then when we draw it, we're going to do so self yes, so var x equals 0, var y equals 0, and then actually no, we do for 0 to self.map height. This will be y. This will be x. And then const index will equal to self.map.width times y plus x. And then the char will be self.map.cells get index so yeah, we don't have these anymore. And then we need to do the c dot code point, draw text code point, c dot get font default, code point is char, position is going to be I'll do that pos, font size, let's do 10, c dot white, so const pos equals c dot vector 2 x and y. It's going to be x times 10, y times 10. I'm guessing it will, because this is going to be usize and it might want this in float, so we will do at float from int fact, let me do that. So this can be a float. And it doesn't like that, so that has to be as f32. They changed the syntax recently in Zig, where it used to be this float from int function, you'd put the type in here, but now they've changed it where it tries to infer the type, but sometimes you still need to do this as. I'm not really a fan of it. It's a little bit more, seems more unnecessarily verbose, but I'll probably get used to it. It definitely encourages you to get your types right as high up in the stack as possible. So let's see, does that work? Hey, okay, that works. So this is using the full input data. I don't know if I do test, will that work? Yes, okay. That's working quite nicely. I I'm going to push this. There is a way to do that. If you go to the cheat sheet, is it begin mode 2D? Or if I go to the drawing functions, which would be not in our shape. I think it is set mode 2D. Yeah. If I do this, see that begin mode 2D, I'll have to do cam defer c dot end mode 2D. Does that not take a cam? No. And then const cam equals c dot camera 2D. I don't know what this takes. Offset, rotation, target, and zoom. Rotation would be just 0. Zoom would be 0. Target equals c dot vector 2. Offset equals c dot vector 2. And this would take an x. So if I did like 50 and y equals 50, will this offset everything? Yeah, target. I do need default values. Is it like a c dot? No, okay. Just checking if there's an empty vector constant. That doesn't work. Is that too much? Is this in clip space? Does zoom have to be 1? Aha, zoom has to be 1. Alright, let me try 50-50. There you go, okay. So that can move it away from the corner a bit. This will be useful later on where I might, once the map is so large, I kind of just want to be able to pan around it. With the arrow keys or WASD. Okay, so let's do this. So okay, now what we want is I want to define different types. So we're going to have a various cells. So we're going to have a digit cell, and we're going to have a symbol cell. So a digit cell will obviously have the digit char, which will just be a U8, but it also have the whole number it's part of. Or a number in, because it depends if in this map each whole number is unique, i.e. it never repeats. I suspect that's not the case, because then we could just use that as its own key. But if there are repeating whole numbers, then we kind of need to put each of these into an array and then use the index of that array as a key. So I'm going to do whole number key, which will be I'm just going to say a U size. And then the symbol cell, again, will just have a symbol char, and then we will have a cell which will be a union type, or an enum union. So it's either going to be empty, in which case it will be void. It will be a digit, which is a digit cell, or a symbol, which will be a symbol cell, right? And then this cell array will no longer use these, it will be cells. I'm just going to leave spaces between each of these types. And then we're going to need a const, a number array. And this number will be, I'm just going to do I32 again. We'll say there's 20,000 of them. And then we'll have numbers, which will be a number array. We will need to initialize that. I'm going to move this init logic down into map. So we will have a hub fn init, which will take an allocator, and it will return a map or not, or an error. And then we'll do a var map equals try allocator create map, and then equals map, and it will have cells equals try cell array dot init, and numbers equals try number array dot init, and then we will return map, and it's going to return a pointer to a map. So we are allocating this on the heap. And just for, we're not going to dinit. So mar equals try map dot init. That takes in our allocator. We no longer need that. Okay. So here's now where we do this. So we no longer are going to append that there. What we'll do is if standard.ascii is digit, this is where we'll handle numbers. Else if standard, what can I use to check? Oh, if char is equal to the period, I feel like that should be the first case. Let's just handle, because that's probably the most abundant case. So we'll do that there, okay. So then we'll do map what did we say it was? Empty. So we'll append an empty cell. Then we'll numbers. Otherwise, it is if it's not alphabetic. If it's not alphabetic, we'll handle symbols. Else we unknown thing we'll probably just panic here. Panic. Unknown character in day 03 puzzle input. There we go. Okay, so to handle numbers, we did this before, so const number equals try parser read number I32. Then we need to do map.numbers append the number. This doesn't return the index, so now to get the number key, it will be map.numbers.len, and then we'll try map.cells append, and it'll be map.cell it'll be digit, right? Digit, which is a digit cell which has the digit char, which is just equal to char, and the, what did I call it? Whole number key. And for sake, let's make sure we are this is the whole number. Oh, I need a, there you go. Okay. And then this would be try map.cells append, and this will be a symbol equals symbol char equals char, right? So what I call it, symbol char, yeah. Let me just make sure that compiles. Okay. What's wrong? What is wrong? Okay, so our draw function needs to update. We will need to see the index here. So our cell equals self.map.cells get index. Then we need to switch on that cell. So if it's a empty, we won't draw anything. If it's a symbol, we will, and if it's a symbol or if it's a digit, then we will do this. So this goes up. But this will give us different types. So we'll do symbol, and then this would be symbol char. We may need to hoist this into a function, so I will do that. I'll hoist this up. Oh yeah, okay. I'll do fn draw char. and this will be x u size y u size and char u8. That way this can just become draw char symbol dot symbol char, and if it's a digit we'll capture the digit, and again we'll draw char digit dot digit char. So, does that work? Still no. Expected 3 arguments. Oh yeah, and then of course I need to pass in xy. Yep, so I can run this. Oh, we got a error. Index out of bounds. Index 72 led 72. Ooh. Is that here, drawing? It must be, because it only happens once I hit this. Okay. For whatever reason, I'm gaining a this index I mean, there's 10 characters there. It should be 10 by 10. So why, oh why? Oh, I think I've got a function for this. Parser, yeah. That's a bit nicer. Advanced cursor. Parser advanced cursor. Let me just check. So standard, let me print num cells d, and that should be map.cells.len. Should be 100 cells. This needs a try. $72? Why? Oh, of course, because when we read this number, the cursor, when it reads a number, it advances the cursor here. So we actually kind of need to rewind the cursor back to here to then read this digit. Or once it's here, we can read, we know how far the cursor's advanced when it's read the number, so we know how many digits are in the number. So we can do that with a loop. So we need to read number, which is what we do here. And then, okay, so we then need to get our, yeah, const. So we need to do const cursor equals parser dot cursor. Cursor start and then cursor end. Yeah, we need to know how far it's gone. And then we'll do for cursor start to cursor end. And this will just be cursor. We need to append that many cells. So the digit char, the key will be the same for each digit, but the char will be different, and that will just be the line cursor. Right, let me just double check that. It's now saying cells 90, which is wrong. This probably needs to be +1. Sounds like an off by 1 error, because if I'm off by 1 for all 10 lines, that's also, it's annoying me that I've not got the new line in here. There we go, num cells 100, and if I go in here, it's now drawing all these, although it's including a dot after each number. Why? Probably because it thinks that dot aha, okay, so I don't need to advance the cursor. So I think cursor at end was correct, but we don't need to advance the cursor in that case. So we do advance the cursor here, and we advance the cursor here, but not in the number digit case. There we go. Okay, that's looking good. So now we have our map structure all parsed. So that's all our text parsing done. Now to actually do the logic of checking if a number is next to a symbol or not. So we need to get all the symbols and then check around if it sees a digit. And we could scan through each cell and check if it's a digit, but we can also cache where all the symbols are. So I'm actually going to do this, symbol indices, and this is going to be an index array, and an index array again will be a bounded array of usize. Again, I'll use 20,000. I'll just do array size here. And then we need to init that, so symbol indices, yep. is an index array. So if it's a symbol, we'll do symbol index equals map.cells.len, and then we'll do try map. Cool. So now we just need to loop over that. So we'll do map.symbol indices. I want to get this as a font slice. So I can loop over that symbol index, and then our symbol cell would be equal to map.cells get symbol index. We can also compute the x and the y. So the x is equal to, I'll call this symbol x actually, which is going to be an I. Yeah, let's do it as I32 for now, because we want to be doing subtraction on it. So we want it signed. So that will be the symbol index modulo the map width, and symbol, the y coordinate is going to be the symbol index divided by the map width. I think these need to be incast into the I32. And then, so now we've got the XY coordinates of a symbol. We basically need to loop over this, all of these. So there's 9 positions, but we ignore the symbol itself. So we can do this with 4, 0 to 3. I'm just going to call this K and J for now, and they're not great names. Or I could do adjects. No, because I need to. Actually, okay, I'll call this local adjacent X, and this is local adjacent Y. I always prefer looping over Y first than X. I'm going to say this is relative. Rel for relative. And then we need to convert this into absolute adjacent X and Y. So const, we'll call this abs adjacent X is equal to symbol X plus and this needs to be incast because these will be U size. This is I32 again, -1. So we're going from -1 to +1. You should know the type of that. and then the absolute adjacent y position should be symbol y. And then we'll say, okay, if abs adjacent x is equal to symbol x and the absolute adjacent y is equal to symbol y, we will break from the outer loop. So this is the outer loop. Actually, no, we don't want to break. We just want to continue, right? Yeah, sorry. Okay. And then we need to get the cell. So we'll do const adjacent cell is going to equal to map.cells get. Oh, we now need to convert this back into a one-dimensional index. So I'll do index is equal to it's abs adjacent y times map.width plus abs adjacent x. Map.width is a usize. We want the index to be usize. So that should actually cast properly, I think. And then add cell I, so that gets the adjacent cell. And then we need to check or switch. Oh, another thing we need to check for is if, say we're checking a symbol that's right on the edge, if we're off map. So I'm actually going to put this into a so if it's the middle cell, but also we'll just do is middle cell or is off map so if it will be off map if abs is less than 0, or if abs adjacent y is less than 0, or if abs adjacent x is greater than or equal to the map width, or if the abs adjacent y is greater than or equal to the map height. So if it's the middle cell, we'll continue. Otherwise, we'll get the adjacent cell, and then we need to switch on that. So switch on the adjacent cell, and if it's a digit, we'll need to do something, else do nothing. And for this, I'm just going to log standard debug print and adjacent part number So it's going to find the digit which points to the whole number. So to get the whole number, const whole number that is equals the map dot numbers, and we'll get, and that's the digit dot whole number key. And we'll say to symbol, and that's a char, symbol cell, and we know that's a symbol, so we can symbol dot symbol char. Adjacent cell I, yeah, it doesn't like that, so I'm gonna have to do this whole int cast thing. So this has to be usize this will be x. What doesn't it like? Access of union while field empty is active. So this symbol index, oh, it'll be -1, won't it? The index is there. Let's try that. Okay, so found adjacent part number 114. Well, that's not right. 633 is correct, but it's the wrong. Okay. And then it crashes because we're getting an index out of bound. All right, let's do some more debugging. So we want to just put a debug thing here. I'm going to say, okay, checking chords, D. So this is going to be apps, and this is going to be let me just run that. So checking chords x20. Let me also do symbol DD. So this would be symbol X, symbol Y. Symbol 3, 1. So this is 0, 1. 0, 1, 2. This is 0, 1, 2, 3. So symbol 3, 1, that's correct. So we then should be checking chords to 0. So that's 0, 1, 2. That's correct. However, we're now getting adjacent part number 114, which is the wrong part number. So are we doing the same problem here where the whole number key, I need to subtract 1 from that because it's pointing to the next number in the array, which is probably why we were also crashing. So let's give that a go. Okay, at least it doesn't crash now. And it's doing this. Okay, so symbol 31 found adjacent part number 467 to this, yes. And then it looks like it jumps to 35, so it's not counting 114. Let's see, 633 next to hash, that's correct. Okay. Okay, so this is working. So I can cut you out. Let me just reduce the font size a little bit. And close you. And we've found adjacent part numbers. Let me just double check this. So now the problem is, obviously, we're getting multiple reports of the number. So really, we want to put these whole number keys into a set. Does zig, if I do zig standard docs, do we have a set data type? That's a set of strings. I guess we could create a set from a hash map. We do an auto hash map. Comp time k and v. I believe if you create a hash map with if I go to source, with the value type as void, it's basically a set. I remember reading that somewhere. Can I just look for hash map? Let's try it. So let's create a var part numbers. It's going to equal a standard auto. Let's do an auto array hash map, and the key will be a usize, and that will be void, and we need to init that with our allocator. And then it's just put, right? And then we'll just put a null pointer. We don't need the whole number. This needs a try because it can fail. Clubbers any existing data yet. I believe we don't need the actual symbol cell, so we can get rid of that. Ooh. And then part numbers, keys. We can actually do that. Part number key, and then we can just print that. Part number is map.numbers part number key. In fact, I'll call this get. That should work. Where's my logs? There we go. So we got part number 46735 633 617 592 644 simple. So we can start to do this. So I can do part number sum, which is I'll do I32, starts off as 0. And then we'll do the part number sum plus equals number. It was the sum of numbers, right? What is the sum? Oh, I'm looking at part. Sum of all the part numbers, which was this answer here. Let me just put that to remember. So the answer is part number sum. I'm not going to print that anymore. And then to draw the part number sum, I did do this in day 2. I think I've already got a function for it called draw raylib.draw answer. I made a helper function for it. So in our draw, we'll just do this. So font size, let's do 30. Font color, we'll just do white, and it will be the answer. Let's quit and reload it. The answer is 4361. That's not right, is it? Oh, sorry, yeah. This one is 4361, that's correct. So now let's try or actual puzzle input, which is day 03, which is here. and have a look at that. I got 525911, which I believe is our actual answer, 525911. So we are getting the correct data. You'll notice you might not hear it, but the music is stuttering because it's trying to draw so many characters on screen. It's actually drawing all of them, even though some of them go off screen. So I want to improve this somewhat. So I'm only going to draw a subset of these characters. So that should be simple enough. So here, instead of doing all this, I'm going to create a new variable called draw width, and it's whatever smallest. Well, let's say we only draw 100 by 100. So const draw height. So we'll only draw up to this. Even that seems a bit too much. I'm going to bump you down to 50. Oh, wait, the other way. Oh. Draw width needs to be here. There we go. And then I want the arrow keys to be able to move around this map. That's still a bit much, isn't it? So let's do, say, 60 by 40. It's a bit better. So that's going to remain constant. Draw x so from draw x to draw y. And then, okay, what I'm going to do is actually this needs to become a member variable. I'll call this map draw x. Map draw y. Oh, I don't need to define those there. Oh yeah, so map draw y and map draw x. And then we'll do, okay, if C, I'm just looking for the function names, is key down C dot key right. I will do map draw x plus equals self. Oh yeah, this needs to be self. C is key down, key left. I'll do self.map draw x. We need to make sure that this doesn't go off screen. So left is E and self.map draw x is greater than 0, then we can do that. And self.map draw x plus draw width is less than self.map.width. Of course, this is a const, which we can't change. Why did we make this const? Yeah, I can hoist these out. These can just be global to day 3. In which case, we no longer need self. Oh, we need self there. So if I do okie dokie. So actually we want from here to map draw y plus map draw x plus. Map draw x plus draw width. And end y, map draw plus draw height. There we go. So this would be until map draw end x and map draw end y. That should be yeah. So that's moving through there, and then we want to keep the map kind of in the same, so we're sort of moving the map behind a window rather than moving a window over the map. So to do that, we just need to instead of passing do we just subtract? Map draw x? Does that work? Oops. That was funky. There you go. That's cool. And then we do the same for up and down. So if C is key up and map draw y is greater than 0, we'll do map draw y minus equals 1. If C is key down, C dot key down, and map draw y plus draw height is less than self dot map height, then map draw y plus equals 1, and then for this we'll minus map draw y minus map draw y. Ta-da! And then we can start to mess around with this. So if we zoom in to 2, it should be twice as big. So that's probably too much. Let's try 1.5. It's a bit better, although now the font is all a bit bleh. I'd rather keep the zoom at 1 and just change the font size. So I can just do font size, you know, make that 15. That goes there, that goes there, that goes there. Is it just because it's not a power of 2? I don't know. Why does it look so ugly? Let's try 14. I hate it. What happens if I do like 30 but I scale it down? It's still really ugly. Is there like something I can do to make the aliasing nicer? Let's have a look. Alias. No. Sometimes it's like a window flag. Might be a Google thing. Greylib, anti-aliasing. Set config flags before your init window. Let's give it a go. Can't tell if that's better or worse. Try 1.4. Yeah, I don't see any difference. Let's just keep it at 1, and we'll just try and make it more central. I think this needs to be like 300. No, 200. There'll be a mathy way to figure this out, but go on, let's figure out the mathy way. So the width is going to be the font size times the map width. So const font size, say font size is 10, window size equals font size times map.width. And then so the offset would be well, I need to know the screen width. I'll have to put this somewhere, probably raylib. There you go. 1080, 720. So this will be raylib.screen width. Ta-da! Do I use these anywhere else? I do. So that is window size plus raylib. Oh no, it's raylib dot screen width minus window size divided by 2 sum to window x. There you have it. At float from int yeah. Oh, it's okay. This goes there, so it'll be window size is actually by the draw width. Is that centered? Doesn't look centered to me. center window y is raylib.screen height minus that's at float from int that's supposedly center, but yeah, okay. Cool. We will draw a nice big rectangle under all that. That'll be 0 to 0. It will be draw width, draw height. It'll be c dot black. We'll need to incast this to a cint. This isn't working. Draw rectangle, 0, 0. Oh, times font size. Seeing as we are reusing this in draw chart and here, this actually can be hoisted out to here. Yay. And then we want to mark the cells that are answer numbers. So, this number array here, I'm actually going to change it to be a part number. So const, or I'll call this a number, it's going to be a struct, and it'll have a value which is i32 and is part, which will be a bool, which is false by default. So this number array contains numbers. So if we come to our function here where we create a digit, we append whole number. So actually we append a map.number whose value equals whole number. And then this part here, part numbers. Oh yeah, we're just putting the key to it. And then this becomes number.value. we're going to pass in the color now. But now the digit requires a bit more logic, because we need to do the digit dot whole number key. So the number is equal to the map dot numbers dot get it's the self block map. And if we come back up here where we put this, we also need to say map.numbers we're going to access the buffer directly now because we're going to mutate it. So the digit whole number key is part now equals true. Do that first. And then the color is going to equal if number color. I think that makes sense. Except that's not working because this isn't taking color. So we need to take color, get rid of hue. There we go. So now it's showing and everything that isn't next to a symbol is marked in red. Cool. So that is that, and then draw answer XY. This would be 0, let's say negative 30, negative 40. There we go. Beautiful. So now we can move on to part 2 of the problem. So where am I? Here. So part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast though, maybe something is still wrong? Fortunately, the gondola has a phone labelled help. So you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. In this schematic there are 2 gears. Okay, so we basically now need to just filter out any symbols that aren't star. Then we need to filter out any stars that aren't adjacent to exactly 2 numbers. And then once we got that, the first is in the top, yep. So the gear ratio is just multiplying those two numbers together, and then you sum all those gear ratios. Again, I have done this part before, but we're just doing this from scratch. And it was like a month ago that I did it. Okay. So that's fairly easy to filter out for symbols, right? So we just come up to where we are parsing our chars. So if it's a digit, that's where we do the digit. So actually what we want to do here is we're just, if it's not alphabetic, which is a symbol, what we'll do is actually char equals dot this. If char equals star, we will append else we will also just put in an empty. We'll just call these empty cells as well. There we go. We'll filter out for these. So we can now verify this with our code. Now we're only seeing stars. So we're going to get a lot more reds, which is cool. It's really nice being able to visually debug things once you've got something visualizing it. Then this is where we need to only consider gear symbols that have exactly two adjacent. So how do we want to do this? Let me think. And let me refer to some old code. Okay, so there's only okay, so what we can do then is we can say, okay, I'm going to call this gear number indices, and we only expect 2 of them, right? And it's undefined by default, and gear number count starts off at 0. So if we come across a digit, we're going to say gear number indices gear number count. We're basically doing our own bounded array, lightweight bounded array. So this will be gear number len, right? So gear number len is going to equal to the digit, the whole number key. And then needs a plus equals 1. However, we, for example, for this, it's going to add the index for this number, the key for this number, 3 times, because we would be, actually no, it would be adding it twice. Would it? If the star was here, for example, yes, it would be adding the key for this number 3 times, because it's going to go over this digit, this digit, this digit. So what we can do is we can check. Again, there's only 2, so we can very easily just do, okay, if gear number indices 0, whole number key, or tell you what, I want these to be optional. So gear number indices 0 starts off as null and 1 starts off as null. We might not need this variable. So if we already have, then we can break. And it will be the outer loop. So we want to break out of the outer loop. Yeah, we can just do this. If gear number indices 0 equals null, then equals else if gear number indices 1 equals null, but then there might be a case where there's a third. So if else, yeah. So if we come across another new number key and these 2 slots are full, so we don't need this gear number length, and these 2 slots are not null, then we're actually going to nullify them and break from the outer loop. We won't set the part numbers yet. And then after this, we will check if gear number indices 0 does not equal null and 1 does not equal null, then it's a part loop. So this would be and 1, and we'll unwrap that optional. This needs to be more like if gear number indices isn't null, and then if gear break and it's the same for 1. There we go. And it's outer loop. I could put this into a for loop, but it's only two indices. So gear number is yep. So this should hopefully work. So now only when there's 2 adjacent should it be highlighted. So let's try and find, yeah, there's only 1 adjacent to that. There's only 2 adjacent to that. Only 2 adjacent to that. This is looking so far so good. I can't find any examples of a star that is adjacent to 3 or more. There are definitely examples of a star adjacent to only 1. So I potentially could remove some of that logic, but at least it's robust with that logic. Tell you what, I mean, let's test it. So, for example, this 454 multiply star 674. Let's find that in the puzzle input. So if I put in like 222 there, yeah, so it's not going to count that anymore because it's got 3 part numbers next to it. This will be ... Make sure that still works. Cool. So now all we have to do, I can get rid of you. This is okay. So this now becomes the gear ratio sum. I'm going to move that up top. This part numbers is no longer needed. Gear ratio sum. So we'll just call this gear 0. So this is gear key 0. And gear key 1. And then the gear ratio is just map.numbers get dot value multiplied by map.numbers and the gear ratio sum plus equals gear ratio. This is no longer needed. This will become the gear ratio sum, and the answer we are expecting is this number right here. Expected answer, runtime answer. Let's check if it works. The answer is this. That's been copied to my clipboard automatically, and there we go. That is everything. I'll just leave this running as I do my outro. So thank you very much. That is day 3. Took me a little while, that one, even though I have done it in the past. I forgot a lot of how I implemented that. Well, it's quite a fun one. I like the visualization of this. Of course, all my other days still work, which is nice. Yes, I'll see you soon. Hopefully, I'm gonna try and get these Advent of Code videos out a lot more frequently. January is a good month for recording videos, not as busy as December. So hopefully see you soon. Goodbye.